All right, this is a video. I hope it's going to work okay. I'm somewhere else again. And it's a video about sculpting. Hetty sent some survey out and asked people's frustrations in modeling. And I think the biggest thing they said was, the sculpting can really stink. It can be suckle. And at the same time, I'm working with somebody, not on a project in Peru, but in somewhere else. And we're working where the project receives revenues in local currency. And when it receives revenues in local currency, the escalation rate for the solar project goes up with the inflation rate. And I'm going to pretend it's in Peru. Now, there are also two different debt facilities. One is assumed to be in USD, one in the Peruvian currency, soles. I hope I abbreviated right, maybe not. That when you look on the internet and try to find a forward exchange rate that could hedge the currency risk of the USD against the soles, even if you're not going to do it, that could do it, it's not there. So we're going to have to make some sort of assumption about what the exchange movements are going to be. And then the debt is sculpted, and of course, since it's solar, it has some seasonality. That's it. Now, here's the biggest theme I have for this sort of situation. I think it's a little bit complicated, and we're going to try to make it reasonable at least, and we're going to try to make it so you can understand it. And my idea, number one, is to use our formula, and everything for me in sculpting comes around this first formula that I have. I should be able to kind of do this thing where you show bullet one and bullet two, but I cannot. Sorry about that. We can compute the target debt service as CFADS divided by DSCR. We can, if we have to fix the debt. And this was another issue. There's a maximum debt to capital in this situation. We can compute the implied. I call it the LLCR sometimes, and we can compute a DSCR, a flat that works if if we're constrained by the debt, and that is we take the PV of the cash flow available for debt service divided by the debt at COD, the total amount of the maximum amount of the debt commitment, maybe, if you want. And we can use this as the DSCR. So I guess we could put in here, either it's going to be an input DSCR or it's going to be this. Now, if we have multiple issues, we adjust this formula and say the CFADS on the very last issue, it's going to be the CFADS divided by our total DSCR on all the issues. And we got to subtract some other debt service, which could be using the same sort of pattern or a different pattern, could be fixed. Now, that's just the first part. The second part is, and I'm going to work through this with you, that if we have a different currency, so let's say we want to do all of our currency in soles. We want to make our model in soles, but we have a USD facility. Now, that, of course, would be horrible in a way, because we introduce currency risk in our project. Because if our exchange rate changes and you still have to pay USD, and maybe you have more devaluation in your currency, that means you have to pay more and more USD, and you lose something. And what we can do is compute if we have an exchange rate in our model, we can say 1 plus that USD rate, if we're changing it to soles, times the percentage change in the exchange rate. And I think, oh shit, that should have been times 1 plus the percent change in exchange rate minus 1. Then we can use that to get a new get interest rate that's effective in soles. Or if we want to do it the other whole way around, we could do USD as our base currency. The CFADS is in USD, everything's in USD. We take our soles debt and we reconvert that to USD. Of course, you better be really careful then and make sure if you're just having a PPA, a price that escalates in USD in soles, you better adjust that too. Oof. Oh. Then when we put things together, this has driven me crazy for so many years. When we can put our debt schedules together, we can say, here's our debt in USD, here's our debt in soles. If our base currency is soles and we have a USD facility, we can put a translation adjustment. If our base currency is USD and we have a soles debt facility, we do it the other way around. Now, the next thing I think is key for me, you can do it a different way, to be sure. A lot of these things you can. I like to compute a debt IRR. The reason I use a debt IRR is because then, and we have a circular reference associated with this. If we have a debt IRR, we can use the debt IRR to compute the present value of the total debt service. It's kind of like a weighted average interest rate, but it's not. Don't try to compute a weighted average interest rate. That's going to mess you up. I went through that with Hetty the other day. No, you have to do, especially if you have a tenor that's different. And you have interest rates that change on the facilities and you have different exchange rates, it's all going to come together in the debt IRR. And that debt IRR can then be used to compute the present value of the debt service, which is kind of I cannot believe I didn't put this formula down. How could I not do that? The PV of debt service equals debt at COD, something like that. Okay, if you use these equations and don't try to force it with some kind of, seen people force pretty simple things, some kind of goal seeks and macros and solvers and all that, what a mess that will be. And then in this example, you have this big model, you have a monster model, and it's got circular references associated with the interest during construction and the DSRA, and it's got all sorts of different things. And if you try to immediately put this kind of stuff in your model without working through a simple example, and that simple example will show you that what formulas really work, and whether when you put, for example, your yield in a different currency, and you take that percent change in the assumed currency, you work through it with a simple example and make sure have these formulas all right. Because when you try to do that in a complicated one, it'll drive you crazy. It would drive me crazy. And then it shows you where to put the things. What kind of structure should you make? And then finally, with a simple example, you try to remove as many circular references as you can. You can put them back later. And of course, I am desperate to show you how my horrible life works, where I have this UDF that I'm trying to get somebody to really use. Maybe I'll market it one day. I see all this other crap. I'm in California today, where they can make these whatever they call them, these Silicon Valley ventures out of nothing. We developed this ourselves. I just want somebody to help. Now, to do this, I didn't mention to compute a exchange rate with purchasing power parity, not perpetual pending projects, public-private partnership. No, PPP, purchasing power parity. If you don't, you can adjust it, fine, but start with this and don't distort your analysis without it. So now what I'm going to do is I'm going to go through more formulas, but there, when we compute the yield on, if we have one currency to the next, we can compute the yield using that formula I just showed you. And I don't know why I didn't put it up here again. One plus the exchange rate. No, I did it right here. One plus exchange rate times this, or we can compute the debt IRR of your thing. So we take a currency in USD, switch it to soles, and compute the IRR on that. Or you can compute exchange rates, and you can, once you get your exchange rate translation loss, you can see how it varies period by period. And when so now I'm gonna come back to these next couple of slides as we go through them all. So let me show you our model now. Okay, so I made a very simple model. I tried to make it simple, but I said, okay, I started with a solar model, and I was going to walk you through some of these things. And you know, the one thing I'm gonna make you do. Oh God, I'm gonna do a. I changed the generic macros around, and I'm making another thing. And so this time I put Control Alt C or Shift Control C. I put this in, and I didn't make it. That's what I used. And in column B, we have our title column, and I put a flexible color in, which is that nice kind of color if you like it. And then we have our conditional formatting of our true and false, and then we have our links to our other sheet, which I used a green background and a white foreground, and I didn't have anything here. Okay, good. And then in our, now that's going to give us, so what we have is some seasonality. We have a simple yield, and we have, what I did is I started with MWH and backed into the KWP from the MWH. Okay, I did that. Okay, you can whatever. And then I said, okay, I'm going to put a price in our local currency, a capex in our local currency, opex in our local currency, and finally get the total capex and opex, just so I can get a simple example, one period construction, no fancy stuff. And then we'll do this. And oh shit, what I forgot to do here is I wanted to do this. Now, if you want to show which scenario you've taken, okay, I think what I always have to do is go all the way to the left, make sure you start here, and then I go to the home page. Don't yell at me that I'm not talking about the sculpting yet. Just a minute. We're doing different different. So we're putting different exchange rates in that are not only flat, that change. You put this in and you make it equal to this one. And then you press F4 so it doesn't keep it on the row, but it keeps it on the column. And then you put some format in really quickly. And I'm going to make it green. How about a little darker green? And then I can show which scenario I picked. Okay, and then when you do this Control-Alt-C, what you can do is you can reset. And then when you reset, you don't want to delete the conditions. You want to leave those in. And then I'm good. How about I'll make it again, but this time maybe this regular old blue is better. Okay, so that gives you, and then the little thing at the top shows, okay, what's going on. What am I doing here? I'm not presenting here. What is this? What? Oh, man. Okay, what was that all about? And I just screwed up. I'm going to, because what I should have done, oh man, I've got to put a default here. This one, I should have not clicked on this thing. That's what I wanted to show you, and I got freaked out by all this. Okay, let me do it again, and let me pause. Okay. Oh, that's embarrassing. Okay, that's it. Again, Shift Control C. I've made a whole another video on this, updates for generic macros, but don't press this button. That's what I wanted to tell you, and then it won't. You'll keep the conditional formatting. Okay, now here is the model, and what I'm going to go through is I think I'm going to go through some selected examples, and the first thing I'm going to do is save it, F12. Let's save it as a different file. Okay, and of course I'm going to give you this file in some sort of sculpting folder or page on my website. Control Alt C. Come on. And this time, let's put some crap at the top. Let's put 7 at the top. And let's use the same color. And we'll see what comes. And let's put a sum column in here. And it automatically finds the sum column. I'm going to use conditional formatting. I'm going to mark links from the other sheets. And Hetty and I were trying to, there's the sum column going. And what we're doing is we're trying to, and here you didn't waste all your stupid little time on the formatting. And perhaps now I lost what I was going to say. Oh, my daughter's being mean to me. You don't like those extreme colors, so you can change that, whatever. And here's what we do. So I start with some macroeconomic stuff, and when we have the lookup, if you press control and the bracket, the lookup, that control and the bracket, that takes you, who cares? If you press Alt U, because you've got it shows you exactly where you've taken it, and you F5. So with our big functions, lookup, index, SUMIF, index kind of works okay. And if you want to mess around with another function and fix how Excel does that control square bracket, which I think is such a big deal, you can do it. Okay, and in some like German keyboards, finding that bracket is really a pain. I understand. Meine Deutschsprechen ist nicht sehr gut, but I can, but I have talked to people. So here's our Soles. Everything's in Soles, and then eventually we get our cash flow, and of course, here, so this is our Soles cash flow, and I'll press F11, and it's going up because we have a high rate of local inflation. If we did the same thing, F11, and I hope you do that in our USD, we have a very different pattern, and we have to decide how we're going to sculpt the debt. Now, sculpting gets crazy when you have taxes sometimes, because you'll have interest that's a deductible item for taxes, but the taxes themselves are part of the cash flow available for debt service, and I'm not going to worry about that. Now, let's talk about the structure of how you might set this up. And what I would suggest you do is you start with everything. You start with the total CFADS, and you start with the very longest tenor you can find. Control square bracket I'm using, and we have a tenor on the US debt of 17 and a tenor on the Soles debt of 15. So this is the Peruvian debt in Soles and the US debt in USD. Okay? So that's that one. And then we can put a target DSCR in, and the target DSCR is only going to be now. When I do this in this example, and I think I'm going to have to change it a little bit later, I use a true false, and the reason I use a true false is if you have a simple calculation and you're using a debt IRR, which right now the debt IRR is coming from downstairs. There is a circular reference associated with this. So I'm going to go back, and what I would do is start this with just putting some IRR in that's somewhere between the IRR for the one issue and the other issue, which we haven't really talked about yet. Okay, and then I can get the NPV. And the reason I can get the NPV, there's a nice little trick. I'm sorry to have you go through this. If we can figure out what this debt IRR is, then you can get the NPV of all of the debt you have uh, at that rate. Now, this is a semi-annual rate. Percent, I'll put S dot A just so you can really see it. And this gives you the debt in soles. Okay, and then we go up here and our CapEx, which came from our other sheet, and that's why it's green. Took me forever to find a good green color, by the way. And some people might say I'm obsessed with coloring, and you might be right. I tried to compute the whatever it is. Oh, come on! I just did this. This better have worked. Okay, I put a few shortcut keys in the generic macros. Okay, and then you can, the biggest formula of all, the biggest formula is the NPV of the debt service. That debt service has to stop, and you have to have a flag here. And Kenny, one of my favorite people in the world with his fast, would put his flags in a different sheet, then bring them over. Why don't you put it right where you're using it and not have to then go and figure out that it came from another sheet? Whatever. Okay, those are boring blah 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 issues. But this, when I look at the capex in soles, here's the capex in soles. This amount of debt was way too big. And the reason the debt was so big is because we had a IRR in soles that's much higher than the interest rate in soles. If we look at the interest rate in soles, I'm going to bring this back. The interest rate in soles was 7%. That is a lot higher. That's a lot lower. Well, not dramatically much, but enough lower if we have a long-term debt that says we're going to get more debt in our project than we need. Okay, and then so what you can do right there is do some sort of calculation, and you don't need some kind of goal seek for this. All you do is put, well, our maximum debt to capital is 70%. So I'm taking the total capex times the 70%, and then I get the PV of the CFADS. That's the trick. Take the PV of the CFADS, just like that. And then you compute a flat. After that, you can compute the flat target DSCR. And if this is bigger than the target DSCR, too bad, you have to use this, except Hetty has this thing that she has really used and developed, and it's so impressive to have a curved DSCR, to have a customized DSCR. Now, when you put a customized DSCR, I know you're going to fiddle around with it, put individual, this percent, this percent. Try to use an interpolate function. Try to use some sort of pattern, some sort of pattern where the DSCR starts high, goes low, because if the DSCR starts high, you get more dividends. But I'm doing a flat one. And then you make a little test. You say, well, if this is bigger than this, if this is bigger than this, then we're going to use this one. If it's smaller, then we're just going to use our DSCR up here. So this is our big number. This is our aggregate DSCR that we're going to use for sculpting. How about this? Shift. Let's make a F11 again. Okay, that, and you can see because it's in soles, it goes up. But don't worry. Don't worry about these patterns because then after we sculpt it and reconvert it to a different currency, it all comes back. Now is the big deal. So that's section 1. Before I start going into the details, section 2 says, okay, let's start with the debt tenor that has a shorter life. Now don't do this, please. When you do this, if you have some things like this, press Control Spacebar and just make them all about the same size, okay? And it looks like that worked, and the problem is perhaps I should have formatted this with just a regular no decimals. Okay. And we're going to start with a shorter debt tenor. Now, this shorter debt tenor happens to be the one that's in the same currency. And that's good. And that's really good. Okay. And what you can do then is no matter whether you're using the debt is sized based on the total the cash flow. The debt is sized when we have the target DSCR driving the debt size, or whether the debt is constrained by the maximum debt to capital. No matter what, you compute the PV of the CFADS and you get your sculpting, and then at the very end you use a little lookup function to make absolutely sure that your debt is paid off, and you can use that in a test. Okay, and that's our first one. And we needed the debt service from a calculation uh, uh, of that same, I call it the kind of LLCR method, where you take the PV of the CFADS. This PV of the CFADS is only over, and I hope I went far enough. Did I stop there? Yes. It's only over the tenor of the debt. So you have to kind of recompute that PV of the CFADS. Again, the formulas aren't so complicated. We can look at every formula we want and press F2 and see where it comes from, and I'm going to walk you through that. Step 3. Step 3, now it gets a little more crap. Okay, and in this one, he sent a photo. Thank you, Mario. I wonder what you sent a photo of. Okay, Shift Control W. Okay, and so now we're going to just do a couple of calculations. And we said, the USD rate is 2.5%. That sounds great, isn't it? The Soles interest rate, this is 5%. It's 2.5 divided by 2. So it's a 5% rate. The Soles rate was 3.5 times 2, I think is 7%. So the USD rate is lower. That's really good. But we had Soles in, I had a high case. Oh, shoot. I had a high case for USD, and I had 4% for USD inflation and 11% for the Soles inflation. Whew. So that it's actually not that good, because the Soles rate is below the inflation rate. The USD rate is 2. They're both negative kind of real rates, which is kind of crazy, but we'll leave it. No, it isn't. It's 5%. It's a little bit higher. The Soles rate of 7 is a little bit lower. Okay. And what we'll be able to do in just a minute, we'll be able to put different percentages in for the debt. So when we did step number 2 for the Soles debt, I start with 50-50. 50 Soles debt, and we take the total debt we actually finally use at our debt IRR, and we get how much is Soles. And then what I need to do probably is I need to blank out a bunch of these rows and let you make some of these calculations. And for me, one of the biggest things to do right now is to get our equivalent semi-annual periodic rate in Soles instead of USD. And once you have that rate in Soles, then it starts becoming really nice, because you can just put everything, the USD, you can just put in Soles, and you can just use that as the USD rate. And the trick is going up here. Now, up here at the very top, I put the PPP exchange rate, and that's one of the things you should do. So that's 1 plus the USD, the Soles inflation divided by 1 plus the USD inflation minus 1. There's our formula. And if you don't keep a consistent interest rate and inflation rate, you're going to have some funny things going on, and maybe that's okay. Right now, I just heard the euro is higher than lower than the USD for the first time since it started, or about when it started. Somebody said that's because the USD inflation is higher than the euro. What a lot of bull! What a lot of it's the other way around. Maybe it's expected rate or something. Okay. So then we're still in section 3, okay, and we get our this rate that's flat. Now let me just pause for just a minute because I'm going to put a couple of spinner boxes in there. Okay. Why can't I? Now, what I should have done is I should have told you that when you make a simple example up, you want to make it with some different things. And very often, when I make a simple example, I want to make sure it works in different conditions. So if I copy this with different inflation rates, I'm copying this to the model page, putting it somewhere up here. That button, by the way, is for a circular reference. So if I change this to the high case, then I hope those yes, look at this one, for example, 4.48 in the base case, and in the high case, it was 5.02. So we have different exchange rates, and the inflation rates are being used up here in computing the PPA price and the O&M costs and all of that. And so for our step 3, if I look now, in the base case it's 5.44. If it changes around, then it's 4.94. And I'm not going to do the changing rate right now because when we did the sculpting, we can't use the NPV formula. And then I have the 5.89. So I can see kind of how the effective USD rate changes. And when you really try to think about it, it's so hard for me to do. I don't know why. I'm dyslexic, like you can't believe. But if you think about the soles deflating, and if you have a rate in USD, it takes more and more soles to pay off your USD. And if you can think through those kind of things just a little bit, that will help. Now, then you put your sculpting, start with soles, start with then you take away the shorter term currency because we're going to use this formula that says DS on our I call it the capture debt. You don't have to call it that at all. That's my stupid little name. Is CFADS divided by DSCR aggregate minus other. And the other is just upstairs. And we're going to do that in soles. And we have our total we have our total we have our total DSCR in debt service in soles. I debated about whether to make this one so you'd have to fill everything in, and I started doing it, and it took forever. And I thought, oh God, I can't do this. And then we can do so once we have this other, this is the other, that's up here. We already just computed that. That's upstairs. And then we get what's left over. Okay. And so that was our total minus the other. And then we switch that to USD. That's the big deal. And if you leave your exchange rates all over the place. I left them up here, but this time we're going backwards. So this is 1 divided by the 4. It's USD to soles. We have to, if you put them all over the place right at the top, I think then you can start to manage this stuff. Now, when you do your PV of the USD, you can take the PV of the USD in using the USD rate. Of course, you've got to keep it consistent. If you're going to compute the PV of the debt service in USD, use that one. If it's not, use the other one. Whew. And then we make our debt balance in USD. And we make sure, and it should work because the PV of the debt service is the amount of the debt And we take for our repayment, we just go upstairs and find the debt service, take away the interest down below, which is on the opening balance. Never, ever, ever, use the average balance. Oh my gosh, that would be bad. Okay. And then at the end of the day, you can make another closing balance test with lookup. You look up the tenor of the debt against the year or the date up here, and then you pick the closing balance. And then do the hard part, which is not really that hard. But yes, it is. The hardest, you put opening balance. Now, even though the debt is in USD, we're converting everything back to soles. We actually almost really didn't need to do that. We needed to do it with perhaps just the cash flows, which are the interest and the repayment. But when we do this, we can see how much we lost on translation. And the loss on translation, if I can maybe find this upstairs, I tried to put the change in the things and I just missed it. I'm going to have to make it just a little bit smaller. Oh my gosh, maybe that's too small. And you can see that that's simply the opening balance multiplied. And now you got to be careful. I do this. I got to admit, I do this wrong every time. This is how much there's a devaluation of the soles, how much the soles goes up, how much more expensive it is, and the percentage difference between the earlier period and this period. And you take that percentage difference. So if it's a USD debt, USD is on the bottom, not the top this time. And you multiply it by the percent change. And when we did the yield, just to remember when we did the yield, when we did this yield, we used the same one. Excuse me, we used the soles. And if I do this, I kind of have to do it. I am sorry, by trial and error. You can probably think through it a little bit better. Now, once you have that loss on translation, here's the beautiful thing: the total debt balance goes down to zero. And that's what you really want to make sure. So this is the amount of extra soles you have to pay because there's a devaluation year to year to year in the soles to USD. And you get it, so it goes down. Oh, that's a good news. And then you put the interest expense in, and then you take you take the total interest, not the repayment, the interest plus the loss on translation, and look at this. You divide that by the opening balance and you get exactly the same rate, our 5.89. Now, if we would switch this around and make it so the rate changes year to year, notice this interest rate goes up and down, and that's what you can use for your varying rate. And you'd have to use a compound interest factor when you did some sculpting, potentially. So I don't know if you even would in this example. Okay. And finally, you can put your debt service, which is your interest plus your principal repayment. That's just the cash flow that comes out of your pocket. You can compare that to the amount you issue, a debt issue you have in soles, and get a debt cash flow and get the debt IRR on that cash flow. And it again gives you exactly the same answer. Okay, now, so we've got part one. Sorry to be repetitive and review. Part one is the aggregate. Part two is the shorter tenor, or I call this the capture debt issue. No, the non-capture. I can't even get my terms right. Part three is the capture debt issue. And then finally, you're going to compute the debt IRR. And the debt IRR, let's put it all in soles because that's our master or our base currency. And I'm going to add the debt service in soles for both of the debt issues. Then I'm going to put the total debt amount for both of the debt issues. Now, the debt amount for the first issue, that was a big deal that I should have maybe re-emphasized there's an input of 50%. That comes from the green sheet. And that's the total amount we computed, and we needed to have the debt IRR to compute this. Okay. And so we put in the total amount of debt from both of the issues. The second debt issue, the total amount of debt in this issue, came from the sculpting calculation. We've already accounted for the aggregate on the aggregate debt issue. We've already accounted for the fact that we can't use the target DSCR. We have to use something else. Now for Hetty, we could add one more complication in here, and we could put a curve sculpting in here. And that gets a little trickier when we allocate things. So I'm not going to do that on this one. I'm going to have to do this on the next one. But finally, at the very end of the day, we get our DSCR. And we can do this in soles, and we can compute our equity IRR in soles. And this is kind of interesting. We can do our DSCR in USD, and we get exactly the same thing. Exactly the same thing. Now, since our yield was effectively higher on the USD than the soles, let's change this around. Let's see if we can't go to the bank and instead get, instead of 50-50, let's get 70% for our soles, meaning there's 30% for the USD. And then what happens here is if you go all the way down, I put the debt IRR we computed, and the debt IRR we computed was just from the debt service in year 1 and year 2 versus the amount we issue. So this is the amount we issue up here of both debt amounts. This is the amount of debt service. Our debt to cash flow is the difference. We get our debt to IRR, and we have a fixed debt to IRR. I put that in now. If you get really fancy, what you could do is that's not so fancy. You just go, and if you've got a circular reference and want to put it in a different color, you can do that. I'm going to leave that for now. So we get a difference. And all we need to do then is make a very simple copy and paste. Now, I'm going to do this with our taxes and with changing the DSRA, the interest during construction, the depreciation on the IDC, and you get a nightmare circular reference situation. This case, because I used a simple one, we just take the difference and go around, do while the range of the difference is not equal to 0. We set the fixed equal to the computed, and we go around and around, and we have it. And then you can click on the button. But before we do that, let's put it back to 50-50 and remember what our IRR was. In 50-50, oops. Do I have to have my formulas on automatic? They are. With 50-50, I guess this is because it was the base case. With 50-50, and in the base case, I get IRR in soles of 14.9 and IRR of in USD of 11. Let's focus on the IRR in USD. If I would have my high inflation, if my now I get a different circular reference resolution, and I get a higher IRR. That's because there's more inflation, I guess. Okay, we can look at that. Now I'm going to put our base in again. I have to run the macro all the time. Big deal. That's not that big a deal. And I get the IRR in USD of 11.29. Now let's change and put more soles. Let's put 80% now. Okay, I get a difference. I run my button, and now my IRR went up because I've got more debt that has an effective lower yield. And if we can change some of the other debt terms, you could make the soles longer and a debt issue longer and all that. And if we go and review what happened now, we had in part one, we needed this debt IRR way up here, way up here. That came from way downstairs. And we needed that to get the NPV of the debt. Then we figured out which kind of debt we're using, and I haven't done this with the other debt to capital method, although it would work. I'd have to lower the IRR a lot. I haven't bothered doing that. And then now we have 80% in Soles, and the yield, the effective yield in Soles is 3.5%. That's our interest rate. In USD, in this particular case, I'm on the base case, our yield is excuse me. Oh, our yield is 5.44, so it's a lot higher. And we didn't. If we were running our UDF, all we need is that yield in the correct currency, and we can run everything. And finally, we needed to have our little circular reference, which wasn't that big a deal, and we get the same sort of IRR. And if we put our high case in, so right now it's 11.85. If I put my high case in, then I have to rerun this, and it gets to the equity IRR gets to be 13%. So you can look at what the effects of inflation are, and you could also see what happened to the DSCR. The DSCR must have changed as well. If I change this to the base case, here the DSCR is now 2.5. It changes a little bit. Okay, and that's because it's just because of the way the USD debt works. And let's put it now all in soles. No, zero in soles. Let's put it all in USD. Okay, now we don't. Now our debt IRR here of 5.44, our debt IRR is exactly the same because it's all USD. It's exactly the same as, come on, our yield up here. And that 5.44 is exactly the same as our debt IRR. And that is exactly the same as the amount, the interest rate we did when we used the loss on translation. Okay, and now let's just, so I said there are three ways to compute the yield, and I said let's begin with uh, 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 begin with the cash flow and the debt service, and start with SOL. And I said if there are two debt service issues, you need to use this formula, and the theme is to use a formula. I'll admit it took me a couple of hours to make this stupid little example, and I thought it would take only a few minutes, but because it's got both the currency issues and the sculpting issues, and again, the currency issues are kind of resolved once you compute those yields. You put that stuff in the UDF. There's a line that says periodic interest rate, and you just put that effective yield in the periodic interest rate, and then you're all ready to go. Okay, and then you can, if you have two debt issues, I walk through, use the formulas for the shorter tenor, compute this LLCR, this PV of the debt service, make sure it's adjusted for the tenor. For the longer tenor, do the capturing process. You can do it other ways probably, but you're going to get a circular reference. I can't do that, or a goal seek. I can't do this without either a goal seek or a circular reference. Okay, and it's a big deal to compute the IRR, and then you can do this with changing interest rates and everything else. Notice the S the structuring in FAST. Part one, aggregate debt service. Part two, shorter tenor of the debt with the LLCR. Part three, longer tenor with our capturing process. Each one has the adjustments. Each one can have your currency adjustment. You could make your model, if you're really fancy, you could make it switch from soles to USD and put a different base currency, and then you'd have to do the translation adjustment on the other currency, and you can put everything in USD. It's just as easy. Don't think one is better than the other. Okay. And then step four is the debt IRR, which feeds all the way up into the aggregate debt service. I hope this gives you a little sense. The biggest lesson here is to start, and it's a lesson that applies to so much more than just sculpting. Try to get the mathematics right. Don't think just because you can type fast in Excel that means anything. Like for my level is cost analysis, use PMT and PV formulas all over. Not NPV, PV formulas for all sorts of different things. Okay, and then make a simple example like this. And then when you have to put this into your real model, I wish so bad one person other than Hetty would be interested in this UDF method that would solve everything once you get taxes and circular reference related to taxes and everything else. And I think I'll post that. I don't think I'm gonna belabor yet another UDF video unless somebody sends me a message. Okay, and there's generic macros. Why I named it generic macros and all. That's going to be another really stupid, boring old video. Okay, that's enough for this one because I'm running out of batteries anyway.